Hello everyone. In this video, we're going to be simplifying a radical expression or denest a radical. So we have the square root of 7 plus square root of 13, and we're going to simplify this expression. I'll be presenting two methods, and let's start with the first one. So denesting basically means that we're going to write this expression using a single square root for each number. What I mean by that is the depth is just going to be 1. So it's not going to be the square root of the square root of something. Instead, it's just going to be the square root of something plus the square root of something else. And that brings us to this idea. So square root of 7 plus square root of 13 can be written as square root of a plus square root of b, and a and b are rational. Okay? A and b are rational numbers such as 1/2 and 2/3 or 7. And that's what we're going to do. Find the a and b. So that's going to be my assumption. I'm assuming that since this can be denested, then I can write it as follows. So let's go ahead and find the values of a and b by squaring both sides. Always keep in mind that a and b are rational numbers. So when you square root, I mean square, 7 plus root 13 is going to equal a plus b plus 2 root ab. So there's a couple housekeeping items. 7 is rational, square root of 13 is irrational. So this number on the left hand side has two pieces, and one of them is rational, the other one isn't. And the same thing needs to happen on the right hand side. So a plus b represents the rational part, and this represents the irrational part. Therefore, a plus b must be 7, and this must equal square root of 13. So we're going to solve a system. Let's go ahead and do it, and then we're going to find the values of a and b. Okay? And then let's go ahead and compare it to the second method. So how do you find a and b from here? We got ourselves a system like this. A plus b is 7. 2 square root of ab is equal to square root of 13. First of all, let's square both sides here. If you square both sides, you're going to get 4ab is equal to 13, which means ab is equal to 13 over 4. And we already know a plus b is equal to 7. So can you find two numbers whose product is 13 over 4 and whose sum is 7? What does that remind you? Doesn't that remind you a quadratic equation like a trinomial? But since 13 over 4 is a fraction, finding the numbers might be a little hard if you're not practiced enough. But I'll show you how you can do that as well. But let's go ahead and go with the formal route first, which is the quadratic formula. Now, you should know from Vieta's formulas, and we've done quite a few videos on that, even a separate lecture video, that if you know the sum and the product of the roots of a quadratic equation, then you can write that equation. So here's how it works. If the roots are a and b, then the equation is going to look like this. T squared minus a plus bt plus ab equals 0. T, by the way, represents a and b, but I didn't want to write a or b because they would be the coefficients. Make sense? Okay. So let's go ahead and plug this in and find our quadratic equation and then solve it. A plus b is 7, so this is 7t plus 13 over 4. By using the quadratic formula, you can multiply by 4, but that's not necessary. Negative b plus minus the square root of b squared minus 4ac. The 4 will take care of this fourth here, and that's going to give you b squared 49 minus 4ac, and that should give you just a 13 divided by 2. And the square root of 49 minus 13 is just 6, so that's going to be 7 plus minus 6 divided by 2. And if you separate it, you're going to get 13 over 2 and 1/2. Let me tell you something. You could also guess those numbers from here. Think about it this way. A and b are both rational numbers, and their product is something over 4. So I'm guessing they're going to be something over 2 and something else over 2. So it would make sense to try something like, and since 13 is prime, that kind of makes it a little easier. How about going with 13 over 2 and 1 over 2? And that actually works because the product is 13 over 4 and the sum is 14 over 2, which happens to be 7. So you see, it quickly ties back to the original equations. So those are the t values, but what is t? T represents a and b, so those are the a, b values that we were looking for. Therefore, we can now write square root of 7 plus root 13 as square root of a plus square root of b. And again, it doesn't matter which one is which. This can be a and this can be b, because they can switch around anyways. Square root of 13 over 2 plus square root of 1/2 would be the answer. But let's simplify this a little bit. We can write this as square root of 13 over square root of 2, but since they'll have a common denominator, I can kind of do it like this, and then rationalize the denominator, and you'll end up with the following, which we should verify with the second method. If you distribute, you're going to get square root of 26 plus the square root of 2 divided by 2 in the simplest form. One can also write this as 1/2 of square root of 26 plus 1/2 of square root of 2. If you seriously want to write it as, a root b plus b root c, or c root d, whatever, something like that. But that's the main idea. And this brings us to the second method, not yet to the end. Let's go ahead and take a look at the second method. So the second method is a little bit more algebraic. And here's what we're going to do. We want to write this expression in the following form. And that form is square root of x plus y plus 2 times the square root of xy. And why? Because this is square root of x plus square root of y squared inside the radical. And then if you square root it, you end up with square root of x plus square root of y. In a way, we're still setting it equal to something like this, but we're going to do this in a slicker way. We're going to introduce an extra 2 there because we're missing the 2. That's what I need, right? So how do you get it there? Easy. You just multiply by root 2 and divide by it. So just insert the square root of 2 and divide by that. You're not really changing anything, are you? You're not. So put the 2 inside. You're going to get square root of 14 plus 2 times the square root of 17 divided by square root of 2. And now, by the way, I don't know how I changed that 13 to a 17 magically. This is supposed to be a 13. I guess I got stuck at 17 from the previous problem that we had. Remember the radical that had the square root of 17 in it. Anyways, let's go ahead and fix it real quick. And now we're looking for the following. Two numbers, and this is kind of like going back to factoring, but two numbers whose product is 13 and whose sum is 14. Those numbers are 13 and 1. Therefore, this can be written as square root of 13 plus the square root of 1 divided by square root of 2. And guess what? That brings you the exact same answer. But let's just do a little bit more. Rationalize the denominator again and multiply by root 2 over root 2. And finally, we get the same thing, of course, right? Square root of 7 plus root 13 can be written as square root of 26 plus square root of 2 divided by 2 in simplest form. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.